Imagine the Earth, today, right now. In this world, the skylines of New York, London, and Tokyo do not exist. Instead, the horizon is dominated by forests of giant ferns and redwoods towering hundreds of feet into an atmosphere that is thick, warm, and rich with oxygen. The oceans are not just home to whales and dolphins, they are prowled by leviathans that make a great white shark look like a goldfish. Imagine a world where the dinosaurs never died. For 160 million years, a span of time so vast it makes the entire history of humanity look like a heartbeat. The dinosaurs were the undisputed kings. They didn't just survive, they thrived. They adapted to shifting continents, survived massive volcanic eruptions, and evolved into thousands of specialized forms. They were the ultimate success story of life on Earth. There was absolutely no reason for their reign to end. They were not a failed experiment, they were the winners. But 66 million years ago, a rock, 6 miles wide, a mountain of cold stone and metal frozen in the blackness of the void, was hurtling towards Earth at 40,000 miles per hour. We all know this part of the story. We've seen the animations of the impact, the fire, and the darkness. We call it the Extinction. But what if I told you that this inevitable end was actually a cosmic fluke? A cruel 1 in a billion accident of timing. Think about the physics of that morning. The Earth is a massive sphere, spinning on its axis at 1,000 miles per hour. The asteroid is a high-speed bullet traveling across the solar system. For them to meet it all is a miracle of geometry. But for them to meet where they did, that is the greatest tragedy in the history of life. What if that rock had arrived just 30 minutes later? Or even just 30 seconds later? If that asteroid had been delayed by just 30 seconds, it wouldn't have hit land. It would have splashed down into the deep 5-mile deep waters of the open ocean. Yes, the impact would have been horrific. There would have been tsunamis miles high, wiping out every coastline on the planet. There would have been massive steam clouds and localized fires, but the deep water would have acted as a planetary heat sink. The steam would have rained out in a few weeks, the sun would have returned, the global temperature would have stabilized, and the dinosaurs, the vast majority of them would have walked away from the disaster. Their empire would have continued. Stop and think about that for a second. A 30-second delay, a cosmic blink of an eye, and you wouldn't be here. Your house, your car, your family, your entire species would never have existed. Our ancestors, those tiny, terrified mammals hiding in holes, would have remained exactly that snacks for the raptors. They would never have found the space to grow, to evolve, or to build. Do you think an intelligent dinosaur civilization would be more at peace with nature than we are, or would they have destroyed the planet even faster? I want to read your best dino civilization theories in the comments below. But the universe did not blink. The asteroid did not arrive late. It arrived at the exact fatal millisecond necessary to hit the absolute worst possible place on the entire planet. It hit the Yucatan Peninsula in what is now Mexico. Out of the 197 million square miles of the Earth's surface, the asteroid found the one specific bullseye, a target comprising only 13% of the planet that could turn a regional catastrophe into a global extinction event. The asteroid didn't kill the dinosaurs with its weight. The fire didn't finish them off. The real killer was buried beneath their feet. It was a substance we use today to build our homes and grow our food, but when struck with the energy of 10 billion atomic bombs, it turned the atmosphere into a global gas chamber. The asteroid hit a massive deposit of sulfur. We are going to uncover the geological map of death, explaining why hitting a deep ocean would have been a survivable bad day, but hitting Mexico was a death sentence for an entire era. We are going to visualize the terrifying chemical chain reaction that turned the sky into a giant mirror of acid and ice reflecting the sun and plunging the Earth into a darkness so long and so cold that it didn't just kill the animals, it shattered the very foundations of the food chain. And finally, we will reveal the incredible, almost miraculous story of the survivors. The tiny, overlooked, and insignificant creatures who managed to endure the hellscape and rise from the ruins to eventually become US. This is not just a story about how the dinosaurs died. This is the story of how we were born. Welcome to Y-Zone 360. It's time to deconstruct the day the world changed forever. To really understand why the dinosaurs died, you have to stop thinking of it as some grand inevitable destiny. It was just incredibly, unbelievably bad luck. It was a cosmic coin toss where the dinosaurs bet everything on heads and the universe flipped tails. Let's freeze time for a moment. I want you to look at the Earth 66 million years ago. It's spinning like a giant blue top moving at 1,000 miles per hour. Now picture that asteroid, a mountain of rock the size of a city, hurtling towards it at 40,000 miles per hour. The asteroid doesn't have a brain, it doesn't have a plan. It's just a silent bullet in the dark. It doesn't care where it hits, but where it hits matters more than anything else in the history of life. You see, the Earth isn't made of the same stuff everywhere. It's like a giant dartboard, but instead of different scores, each section carries a different penalty. And most of those penalties were actually survivable. Let's look at the board. First look at the blue zone. That's the ocean, covering about 71% of the surface. If the asteroid hits the deep water here, the result is horrific, but it's not the end of the world. Imagine throwing a white-hot stone into a bucket of water. You get a massive splash, a tsunami, that would swallow coastlines and a massive amount of steam. Now, steam is a greenhouse gas, so the planet would have warmed up for a few years, but steam eventually turns into rain and falls back down. The dinosaurs would have gotten wet, they would have gotten a bit hot, and many near the coast would have drowned. The planet would have recovered. Next, look at the gray zone. This is the hard rock making up about 16% of the surface. These are the solid granite shields of the ancient continents. Hitting here is like a hammer hitting a concrete floor. You get a massive crater and a colossal cloud of dust. That dust would block the sun for a while, causing a very harsh cold winter. It would have been a rough few years, but again, the dinosaurs were tough, they had survived climate shifts before, most of them would have made it through. Because there was one last slice of the pie, the red zone, the poison trap. This covered only 13% of the Earth's surface. These were the shallow tropical seas, places like the modern-day Gulf of Mexico. The reason they were so dangerous wasn't the water, it was what was buried underneath the sand. Underneath the beautiful turquoise water of the Yucatan Peninsula lay a massive ancient coral reef that had been building up for millions of years. And inside that reef were huge deposits of a specific mineral called gypsum. You probably know gypsum. It's the soft white stuff we use today to make drywall for our homes. It seems totally harmless, you can crumble it with your fingers, but gypsum has a secret ingredient locked deep inside its crystals, sulfur. Normally, sulfur is safe as long as it's part of a rock. But if you hit it with a 6-mile wide asteroid traveling at 40,000 miles per hour, you don't just break the rock, you vaporize it, you turn that solid stone into a massive expanding cloud of hot sulfur gas. When that sulfur gas shoots up into the sky and mixes with water vapor in the atmosphere, it transforms into billions of tons of sulfuric acid aerosols. Think of these aerosols like billions of tiny floating mirrors. They don't trap heat like a greenhouse. They do the exact opposite. They act like a giant planetary sunshade. They reflect the sunlight back into space before it can even touch the ground. They don't just dim the lights, they turn off the Earth's heater. If that rock hits the water, we get steam. Things get a little warmer for a while, but life goes on. That's a safe bet. If it hits the solid granite, we get dust. It blocks the sun for a few months, sure, but the dust eventually settles. It's a bad winter, but not an extinction. That's also a safe bet. But if it hits the gypsum, we get sulfur. And sulfur creates a global deep freeze that lasts for decades. That is the deadly scenario. That is the game over button for 160 million years of history. The asteroid slammed into the Yucatan, it hit the gypsum bullseye, it hit the sulfur. That tiny 13% chance became the dinosaurs' reality. The absolute worst-case scenario happened. It is chilling to realize how thin the line is between us being here today and us not existing at all. If the asteroid had arrived just 30 minutes later or 30 minutes earlier, the Earth would have rotated just enough that the rock would have splashed harmlessly into the deep Atlantic or Pacific Ocean. There would have been no sulfur cloud, no global deep freeze. The dinosaurs would have kept on eating, fighting, and evolving. And our tiny mammal ancestors would have stayed in their holes waiting for a chance that would never come. To understand that, we have to step inside the global gas chamber. So the asteroid hit the bullseye, but what made the Yucatan Peninsula such a uniquely terrible place to land? Why was this specific patch of Earth more dangerous than a volcano or a nuclear test site? To understand the weapon we have to look at what was buried underground. Imagine the Yucatan 66 million years ago. It wasn't the dry land covered in jungle that we see today. It was a shallow tropical sea teeming with life. For millions of years, tiny sea creatures lived, died, and sank to the bottom. Their shells, their skeletons, their organic matter piled up layer upon layer, century after century. Over time, heat and pressure turned this organic soup into two things. First, it created oil. The Yucatan sits on top of massive hydrocarbon reserves. This meant that any impact here wouldn't just be a rock hitting rock. It would be like throwing a match into a planetary gas station. The explosion would be fueled by millions of years of stored solar energy, creating immense fires and black soot. But oil wasn't the worst thing down there. The second thing that formed was a thick, vast platform of sedimentary rock called a vaporite. This rock formed when ancient seas dried up, leaving behind layers of salt and minerals. And the most abundant mineral in this layer was anhydrite. Anhydrite is a rock made of calcium sulfate. It sounds boring, right? It's just rock. But inside every molecule of anhydrite is a trapped demon sulfur. Under normal conditions, that sulfur is locked away safely in the crystal structure of the stone. You can hold it in your hand, it's harmless, but an asteroid impact is not a normal condition. At the center of that impact, temperatures soared to tens of thousands of degrees. In that unimaginable heat, the anhydrite didn't just melt, it vaporized. Billions of tons of sulfur were liberated from their stone prison and blasted upwards at supersonic speeds. It wasn't just dust, it wasn't just smoke, it was a massive concentrated injection of sulfur gas shot straight into the stratosphere. This is why the location mattered so much. If the asteroid had hit the deep ocean, it would have vaporized water. Water vapor is a greenhouse gas, it warms the planet, but it also rains out very quickly. A wet impact would have created a global sauna. Unpleasant, maybe a bit steamy, but life would go on. But hitting the Yucatan created a global gas chamber. The sulfur gas reacted with water vapor in the upper atmosphere to form tiny droplets or aerosols of sulfuric acid. These aerosols are lightweight, they don't fall down like rain, they float. They spread out on the high altitude winds, wrapping the entire Earth in a thick reflective white haze. This haze did something that water vapor doesn't do. It didn't trap heat. It blocked it. But what did this actually look like on the ground? What did the dinosaurs experience as their world turned from a lush paradise into a frozen, acidic wasteland? In our next chapter, we will witness the terrifying transformation of the planet. So the trigger was pulled, the sulfur escaped, and just like that, the dinosaurs' tropical paradise turned into a global prison. Imagine waking up the next day. The sun is still there, but it looks wrong. It's dim, pale, barely shining through a thick yellow-white haze that has wrapped itself around the entire planet. It's not night, but it's definitely not day. It's a permanent, gloomy twilight. But the darkness isn't the worst part. The worst part is the cold. Remember those billions of tons of sulfur up in the sky? They turned into a giant mirror. Instead of letting the sun's warmth in, they bounced it right back out into space. The Earth's heater was turned off. Think about the dinosaurs. They were built for warmth. They didn't have thick fur coats. They didn't know how to hibernate. They were like tropical lizards suddenly dropped into the middle of Antarctica. They didn't stand a chance. They slowed down. They stopped moving. And then they just froze. But the sky wasn't done yet. After the cold came the rain. And this wasn't normal rain. The sulfur in the clouds mixed with water to create sulfuric acid. For years it rained acid. The acid rain changed the chemistry of the water. It made the ocean acidic. This was a death sentence for the tiniest creatures in the sea, the plankton, and anything with a shell. When the plankton died, the fish starved. When the fish starved, the sharks and the giant marine reptiles starved. The entire ocean food chain collapsed from the bottom up. It became a silent, watery graveyard. Back on land, the same thing was happening. No sun meant no plants. No plants meant the plant eaters, the triceratops, the long-necked giants had nothing to eat. They were walking engines that needed hundreds of pounds of food a day. When the salad bar closed, they ran out of fuel. And when the plant eaters died, the meat eaters, the T-Rexes, found themselves in a world full of food. For a while. But soon the carcasses rotted and the kings of the world found themselves ruling over a kingdom of bones. It was a slow, brutal starvation. The asteroid didn't need to hunt them down, it just broke the food chain, sat back and waited. It's crazy to think about, isn't it? The most powerful animals to ever walk the earth weren't defeated by a bigger monster. They were defeated by a change in the weather. It really shows how fragile life can be. If the grocery stores closed tomorrow and never opened again, how long do you think you'd last? It's a scary thought. The giants were gone. The T-Rex, the Triceratops, the masters of the planet for 160 million years were now just bones freezing in the dark. The world was a silent gray wasteland of ash and acid. It seemed like the story of life on Earth had reached its final tragic chapter. Meet Purgatorius, a tiny furry mammal no bigger than a squirrel. For millions of years, creatures like this lived in the shadows of the dinosaurs. They were terrified, nocturnal, and spent their lives trying not to be stepped on or eaten. They were the ultimate underdogs of the Cretaceous period. But when the asteroid hit their weaknesses, suddenly became their greatest superpowers. Let's deconstruct the why of our own survival. Superpower 1, their size. A T-Rex needed hundreds of pounds of meat every single day just to stay alive. A Purgatorius needed a few bugs and a couple of seeds. While the giants starved to death, our ancestors found plenty of food in the cracks and crevices of the earth. They were low-energy machines in a world with no fuel. Superpower 2, their home. While the dinosaurs were exposed on the surface to the 500-degree heat pulse in the sub-zero winter, the mammals were safe in their underground burrows. The earth itself acted as a massive insulating blanket. It kept the heat out during the impact and kept the warmth in during the freeze. They were born for the bunker. Superpower 3, their senses. Because they had spent millions of years being hunted, mammals had already evolved fur to stay warm at night and sharp senses to find food in the dark. When the sun went out for 2 years, they were already adapted to the darkness. To the dinosaurs, the dark was the end. To our ancestors, it was just another night. It's an incredible irony, isn't it? The very things that made us insignificant for so long were exactly what saved us. Have you ever felt like your own weaknesses, maybe being quiet or cautious or small, were actually strengths in the right situation? Maybe you're just a survivor in waiting. Share your thoughts in the comments. What if these tiny mammals hadn't been there? If the asteroid had hit 100 million years earlier before mammals had evolved their burrowing instincts? Life might never have recovered. The Earth would be a silent, insect-filled rock. But they were there. They huddled in their burrows, sharing body heat, eating roots and dead bugs, and enduring the long 2-year night. And when the skies finally began to clear, when the sulfuric acid rain stopped and the sun finally touched the ground again, they emerged into a brand new world. Over millions of years, these tiny shrew-like creatures became whales in the ocean, lions on the plains, apes in the trees, and eventually, they became us. This brings us to a mind-blowing realization. The asteroid didn't just kill the dinosaurs, it created us. Without that specific rock hitting that specific deposit of sulfur in Mexico at that exact second, the dinosaurs would likely still be here today. Evolution would have taken a completely different path. Humans would never have existed. The entire history of our species, every empire, every invention, every song, every person you've ever loved is the result of a lucky break 66 million years ago. The story of the Chicxulub impact is a story of destruction, yes, but it is also the ultimate story of resilience. It teaches us that life finds a way, that even in the darkest moments when the world seems to be ending, there is always a seed of hope, a new beginning waiting to sprout from the ruins. But how do we make sure we don't end up like the dinosaurs? In our final part, we will look at the ultimate lesson we can learn from the day the world changed forever. For 66 million years, life on Earth has been playing a game of Russian roulette with the cosmos. We have been lucky, but luck is not a strategy. The dinosaurs had size, strength, and millions of years of dominance, but they lacked one critical thing: awareness. They couldn't look up. They couldn't understand the threat. They couldn't defend themselves. We are different. We are the first species in the 4.5 billion year history of this planet with the ability to not just survive a disaster, but to prevent it. We have telescopes to scan the dark. We have mathematics to calculate the orbits. We have the technology to reach out and touch the asteroids before they touch us. Think about the DART mission where humanity successfully slammed a spacecraft into an asteroid to change its course. That was not just a science experiment, that was a declaration. It was humanity saying to the universe, we are not dinosaurs. We will not go quietly into the night. We are now the guardians of the planet. The torch has been passed from the blind strength of the T-Rex to the conscious intelligence of humanity. So the next time you look up at the moon or see a shooting star streak across the sky, don't just see it as a pretty light. See it as a reminder of the thin line between existence and extinction, a reminder of the incredible luck that brought us here, and a reminder of the duty we have to use our minds, our science, and our unity to protect this fragile, beautiful, accidental blue marble. We have been given a second chance that the dinosaurs never got. Let's not waste it.